In this video, we're going to expand upon our understanding of what chemical compounds are and look at how to learn the atomic composition of chemical compounds by learning how to read their chemical formulas. So just like the way that we read chemistry and basically everything else in English, we read chemical formulas starting from the left-hand side of the compound and ending on the right-hand side of the compound. So this chemical formula here, which is actually the chemical formula for sugar, we would read it as C6H12O6. So we can see here that the 6, the 12, and the 6 in the chemical formula are actually written lower than the element symbols themselves in the formula, which is why we call this type of writing subscript. Remember that the English prefix sub means below, so subscript numbers are numbers that are written below the chemical symbol of each of the elements, and the job of each of these subscript numbers is simply to show how many of each type of atom are found within the chemical compound. So in the case of sugar, the 6 here corresponds to the carbon, so sugar has 6 carbon in a single unit of sugar. The 12 corresponds to hydrogen, and finally the second 6 here corresponds to oxygen, which is why we read the formula as C6H12O6. Now from this, we can see that reading chemical formulas is not actually a big deal at all. For example, if we just make up another compound here, SO3, the two elements that we have in this compound's chemical formula are sulfur, of which there is no subscript number here, and if there is no number here, we can assume that there is only a single atom of that element there, and of course the second element would be oxygen, and we see a subscript 3, which tells us that there are 3 oxygen atoms within this chemical formula. Now, this is all well and good, but what if we have a situation where we have more than one unit or more than one copy of each compound? So if we take a look at this compound here, which is actually an acid that we call nitric acid, we can see from the large number 3 here that this means we have 3 of this compound here. Now, if we have a number that is written in front of the chemical formula itself, you can see that it's not written in subscript form. This is what we call a coefficient, and students that have also taken the right mathematics course will know that a coefficient is a number that you put in front of another number, usually a variable, and the way that the coefficient is applied to a chemical formula is similar to the way that it's applied in math. For example, if we write a simple mathematical expression, 3 and then x plus 2, mathematics students will understand that the 3 is multiplied by the x and by the 2, so this expression actually is 3x plus 6. So the coefficient here tells us that we have 3 of this whole compound here, and you can see that I've written brackets around the chemical formula, and because of this, it's easy to see that we don't just have 3 hydrogen or just 3 nitrogen or 3 times 3 oxygen. We have 3 of the whole compound itself. So once again, if we get this in writing, coefficients in front of chemical formulas are meant to show how many of the compound itself we have in total, and the coefficient actually applies to not a single atom in the compound, but all atoms within the compound, which is why it's helpful to put brackets around it to show that we apply the coefficient the same way we do in mathematics. So if we want to count the total number of hydrogen, nitrogen, and oxygen in this compound, we would simply take 3 and multiply it by each of the atoms. So 3 times 1 hydrogen is a total of 3 hydrogens. 3 times 1 nitrogen is a total of 3 nitrogens. And because we have 3 oxygens per nitric acid compound, 3 times 3 is a total of 9 oxygen. Now, if you want a totally easy way in order to see how this is true, all that we need to do is write the chemical formula 3 times. So if we do this, if we actually have 3 copies of the compound here, we can see that we have 1, 2, 3 hydrogen, 1, 2, 3 nitrogen, exactly as predicted, and 3, 6, 9 oxygen, exactly as we see here. Now, using this simple tutorial, we can see that reading chemical formulas is not particularly challenging at all. You just need to be careful when it comes to counting atoms, as this is a fundamental step in doing more complicated chemistry problems in future subjects and in future grades. So to test your knowledge of fluency of reading chemical formulas, as well as being able to identify whether a substance is an element or a compound, you can take a look at the practice problems below. And if you skip to the practice problems here at number 3, you can take a look at the chemical formulas of each of the compounds listed below, noting both the subscript numbers and the coefficients, and see if you can identify which elements make up the compound and how many individual atoms of each element are needed in order to make the total number of compounds that we see here. And once you're done this set of practice problems, you can move on to the final lesson video in this series, or the final series rather, in which we look at the naming conventions of some simple ionic and covalent compounds.